Hello everyone, welcome to the COMP90054 Pacman project. This is GroupHooha's presentation. First, I will talk about our design for our final AI approach. Basically, we have two agents. One of is the attack agent. It will have the pure attack role, and the other one is the defense agent. It will have half attack role and half defense role. Now let me introduce about the attack role. In the ghost state, agent is not affected by the enemy Pacman state and stay the route to find the food in order to get a score. And in the Pacman state, agent finds as much food as possible to win the game. The agent is implemented by the heuristic search A-star search method. In the defense role, agent will stay in the ghost state and keep chasing the enemy Pacman with trained Q value to keep detect and capture enemy Pacman. Here are the techniques we have used for our project. For the attack role, we have used the heuristic A-star search method for target navigation core technique. For the defense role, we have used the Q value with default weighted agent to capture the enemy. Initially, we want to have the Q-learning trained agent with dynamic feature weighted estimates. Because of the performance, we have given up this approach. Speaking of our implementation about heuristic A-star, first, we have used the heuristic search A-star search method to find the target location by compare every successor's cost. And the second, we have used the avoid ghost heuristic by simply adding the cost of those positions next to the ghost in order to avoid the capture by the ghost. Our Q-learning trained agent works not that well, but we have already designed a feature weight model for defensive agent. And here are the features considered for the defense agent. First, we have the variable non-invaders, which means the number of the enemy used to detect for the enemy. And the second variable is the undefense variable, which is the check if the defense agent is Pacman for offense or is ghost. And the next one is invader distance, the distance between the enemy and the defense agent. And the last one is a stop. It detects if the agent is stopped. We have also designed the reward adjustment to make the award that make the agent active when detect the enemy and capture it. We have three strategies for the attack strategy. The first one is the food search problem, capsule search problem, and escape problem. We have only one strategy for defense. This is the chase Pacman problem. Here comes our decision tree for the attack agent. First, we will check the food left if less than 2 or not. The left side of the statement means that we have enough food to carry and win the game. So we just need to check our statement if Pacman or not. If we are Pacman, we still need to go home to win. If not, we just need to stay at home and until the game to the end. The right side means that we still need to capture for the food, and first we need to detect the enemy to check if we are safe. And if we detect the enemy, we'll go to the next check statement. We will check the distance of the enemy is greater than 3 or not. If greater than 3 means it's safe to execute the full search problem. If not, we need to check if the capsule exists. If we check there is a capsule, we need to check if it's safe to get a capsule, and we can execute the capsule search problem. And if not, we'll just go home to escape from the enemy radar. And go back to the last statement, if we didn't check any capsule left, we need to check if the enemy ghost is scared or not, which means that we can still run the full search problem or not, or go home to escape from the enemy. And here comes the decision tree of our defense agent. First, we need to check the statement that the enemy eaten food is less than 10 or not. The right side means that the defense agent needs to go back to home to defend and immediately execute the Q value approach to chase the enemy. If the enemy eaten food is less than 10, means that invader is not a threat for us, so the defensive agent can still assist attack agent. First thing is that detect the enemy. If we didn't find any enemy, we can just execute the food search problem on defensive agent, so the defensive agent can eat the food. If we detect any enemy, we need to check that the enemy is scared or not. If it is scared, we just ignore the enemy and keep searching for food by executing the food search problem. And if not, we need to attract the enemy's attention and go home. We have three challenges in the first version of our approach. The first one is the dead-end problem. The second challenge is the permanent chasing loop. Our agent could not find an efficient way to escape. We have added a capsule search problem strategy to solve this in the version 2. The next one is a detect enemy challenge that our defense agent could not find the enemy efficiently. We have modified the chase Pacman problem strategy, which defines when one of the agents detects the enemy Pacman's position, they share the information so the defense agent go capture the enemy. In our version 2, the first challenge is the capsule trap, that the capsule didn't be checked safe or not to be eaten. We solved this challenge by comparing the distance from the enemy to the capsule and the agent to the capsule. The next challenge is the no capsule challenge. Our agent still find difficulty to escape. We solved this problem by let the agent go home to escape. The last challenge is the barrier challenge. The enemy will stuck on the only way that's our agent to the food. We solve this problem by letting defense agent to attract the enemy's attention, so the barrier will be removed by our defensive agent. If we got more time, we will keep develop Q-learning approach by adjusting reward value and add more reward cases to improve the performance.